No city skyline would reach these heights if it weren't for this machine. Before the elevator, buildings rarely grew over 5 stories. They perform billions of rides every day around the world. Among the safest ways to travel, there's less than 1 chance in 12 million that something will go wrong with the elevator you're riding in. Let's see how they work. The most popular elevator design is the roped elevator, where a car is raised and lowered by steel cables. The machine's muscle lives up here at the top of the elevator shaft. Its ropes attach to the car and loop around a sheave, a pulley with grooves to grip the ropes that's connected to an electric motor. Turn the motor one way, the elevator car goes up. When the motor turns the other way, it goes down. A counterweight lives on the other end of the ropes to offset the weight of the car. It's usually about half the weight of a fully loaded passenger elevator. So, on an average ride, the two are perfectly balanced. All the motor needs to do to move the car is provide a nudge to tip the balance one way or the other. This system saves energy as well as wear and tear on moving parts. Once the car is moving, the motor's only job is to control one of the 2 falling objects. Both the car and counterweight are attached to guide rails inside the shaft. They keep everything from swaying back and forth and also give a backup set of brakes something to grab onto. If anything goes wrong with the motor, hydraulic fluid is cut off, and that automatically releases this brake that seizes the ropes for a quick stop. Technically, one of these steel ropes is enough to hold up both the car and the counterweight. The rest are there for backup, in case one snaps. But what if the whole set is cut? Don't worry, it still won't plummet. This machine has a built-in failsafe. There's a governor located beside the motor, with its own pulley and separate cable attached to the car. There are 2 spring-loaded metal hooks called flyweights inside the governor. If a car free falls and the governor spins too fast, centrifugal force pushes the hooks out. They seize ratchets on the fixed inner rim and stop the pulley. The governor's rope jerks on an arm on top of the car, and this locks the brakes. The idea of the rope elevator is simple enough. One side goes up, the other goes down. It just took a couple of thousand years to figure out how to stop it. It's easy enough to drive, but without brakes, we'd rather walk.